All right, so today we're going to focus in on graphing cosine. So first thing I want to show you guys again is on delta math. So real quick before we get to the actual review problems, I want to show you how to do this. So in delta math, by the way, you don't need to attach your work here. So what you're going to do is you're going to be looking at graphs of cosine and sine. It doesn't really tell you what the graph is, but the main thing that you're going to be looking for in this first assignment is the midline of the graph. So if I'm looking for the midline, remember that the midline is just the center of these peaks and valleys, right? So the center of these peaks and valley in this case would be right here along the line there at -1. Because you can see that above it, we go up 3, and then below it, we go down 3. So the middle of it is -1. Now, if it's -1, what that means then is that we put -1 here, but notice it says determine the equation, right? Well, equation of a horizontal line going straight across is the same thing, but you put y equals in front. So y equals -1 is the equation. So whatever your number is for your midline, basically put y equals in front of it, and that's the equation for the midline, right? So if I do one more of those, let's say this one, midline, looks like it's right here. This is also this, oh, sorry, this is actually the same problem. Sorry about that. All right, let's go to the next one. All right, so here it looks like our midline is right there. You can see it's 2 above and 2 below. So that's right where our midline's at. So that means it's -3. So then for here, I'm going to put y equals -3. Okay, so that's pretty much all how you do those. Okay. So the next one, the next section is amplitude. So we're now looking for the amplitude of the graph. This is the number 2 here, the second one. All right, so the amplitude is the distance away or above the midline and below, or the distance away from it. All right, so if I draw the midline here at 2 this time, the amplitude is just how far is it above and below. And you can see that it's 1 unit away. So it's just 1 in this case. In this one, you don't need to put the equation. It's just asking for the amplitude itself. So that's all you put there. Okay, so let's go to the next one. Yeah, but we're going to continue to do a couple here. So now, in this one, here's my midline. We just got to find the middle of the graph. And I got to figure out what is the amplitude. The amplitude is above and below. How far away is it from that midline? In this case, it's 2. So then here, all I do is put 2. Okay, so that's how you do those. All right, next section. Okay, so the next section is now you are basically given a graph and you have to change up the equation in order to fit the new graph, which is this dashed line. All right, so first of all, wherever you guys, this part right here in the middle, I want you guys to just put a 1 every time. So just put 1. All right, because what this changes is how long it takes for this graph to repeat itself. And you can see that it comes down, it comes back up, and then it starts to repeat again at 2 pi, or if you guys remember, that's also 360 degrees. But we're not changing that, okay? So at least in this delta math. In the future ones, we will. All right, so this one, just put a 1. All right, so all we're worried about is this number in the front and the number in the back. So first thing I need to do is look at the graph and say, okay, where is the midline here? Well, you can see the midline is right here at 2. So what that means is that the vertical shift is 2. And then the amplitude is the number that goes in front. So that number, I'm just looking for how far is it from the midline, or how far up and down. You can see that it's 2 here. All right, so that means that the amplitude is also 2. Okay? All right, so then that's it. So what you got to do now is just click try, and you'll see it expand and kind of move. And as long as it fits, it'll give you the button to move on. If you get it wrong, then it's just going to keep on telling you to try again. All right, it won't. You don't get 2 attempts. You pretty much get unlimited attempts. So you can see here they do the same thing. There's the midline, and the amplitude is 2 above. So you put 2 here and 2 there. Okay. All right, next one. All right, so now you can see that it shifted all the way down here, right? So that midline is now here at -4. So that's what I'm going to put in there. I'm going to put -4 since it went down 4. Remember this one, just put a 1. And now the amplitude from that midline Okay, from up to here to the top of that graph is just a 1. So for the amplitude, I just put 1. Try it out. See, it shifts down. Amplitude doesn't really change. And that's it. Okay. All right, that's it pretty much for that section. Okay, so now let's move on to the review. Again, I'm going to focus in on graphing sine and cosine. All right, so now in your notebook, obviously you want to do this in your in your notebook because you have the kind of graphing paper in there. All right, so what I'm going to do on here is I'm going to use the left side of my graph as the y-axis here, and this will be the x-axis. Y, x. Now, at the beginning is 0. All the way to the end here is going to represent 360 degrees. The middle will be 180. And then these marks will represent 90 degrees. So basically, we're going to be graphing every 90 degrees. Okay? And then we'll just go by ones here on the y-axis. Okay? So obviously that's -5, and that would be 5. All right, so first we're going to start with sine, like we did last week. Sine of theta. Okay, so y equals sine of theta. Well, remember that with the unit circle, that we're basically graphing what is the value as you go around the unit circle, right? So if I start over here at 0, remember that the coordinate for that point is 1, 0, right? So then the y value is your sine, right? So the sine and the y value are the same thing. So we start at 0. So right here at 0 degrees, I start at 0. Then as I go up to 90 degrees, the point here is 0, 1. So now that y value changes to 1. So when I get to 90 degrees, I go up to 1 here. And then I come back down to 180. And at that point, I'm at negative 1, 0. And the y value is 0 there. So that means at 180, I'm right on the line. Okay. And then at 270, I come down. And I'm at 0, -1. So now the y value becomes -1, which means that at 270, I go below the line. So it's right there. And then here at 360, I go back to 0. So I'm back on the line. So here for sine, we start in the middle, go up, come back through 180, come down to 270, and go back up to 360. Okay, but cosine is a little different. So now let's graph cosine of theta. Now remember, cosine of theta is all the x values. Okay, so for cosine, we start at 1. So we don't start right in the middle. We actually start 1 above the middle of the graph. Then at 90, the x value for cosine is 0. So at 90, we go back to the middle. At 180, it's -1. So actually, we go below the line, or the midline at 180. And then at 270, we're at 0. So I go up here to 0. And then back when we get back to 360, put 360 here, it goes back up above the graph and like where we started. So here, what this looks like for cosine is we start above, go through 90, then below at 180, come back up through 270, and back to 360. And if you actually move one of these graphs over, like if I shift sine over, like if I shift this point over to here, that's basically the exact same thing. If I shift this point over to here, it's the same. If I shift this point, you'll see that it pretty much matches up with that graph. Okay, I had to pause for the announcement there. So now let's graph the changes in those graphs, right? And again, right now we're focused on cosine. Okay, sine is graphed very similarly. Obviously, we did this last week in week 14. Go back and review that if you don't remember sine. Okay, so we're focusing on cosine. So the first one I'm going to graph is 3 times the cosine theta minus 1. Actually, let's go -4. All right, so -4. So first of all, the vertical shift, is -4. And again, I'm referring back to your guys' packet here. Right here on that first page on 9.7, you're basically going to be given an equation. You have to create the equation. All right, so here at -4, that's the vertical shift, and then the amplitude, the distance from the midline, is going to be 3. So first start with your midline. Okay, it's at -4. So I'm going to go down to -4. Okay. And then I'm going to go from there. Once I have that midline, I'm going to go now refer to the amplitude. All right, now remember, this is the first cosine graph, right? Where there's no changes. There's no change in the amplitude. There's no vertical shift. But notice how it starts above the midline, right? 1 unit above, because the amplitude of this was 1. All right, that was the first graph right here. Okay, the amplitude was 1, so we go 1 above the line. But now the amplitude is 3, so we go 3 above the line. We want to count it out. 1, 2, 3. So there's my first point. Right? I don't go up to the y value 3. I go 3 above the midline. And then for the next value, for the original graph, we went back to 90, right? So we do the same thing here, except we're going to come back to the middle of the midline, okay? Not the x-axis. Okay, and then when we get to 180, that's when we go below the graph. Here we're 1 unit below. Here we'll go 3 units below, because remember the amplitude is 3. And then again at 270, we come back to the midline. And then when we get to 360, we go back above the graph right here. So now I try to make a nice curve, where I curve it out, kind of come down through 90, curve again, come back up through 270, and then to 360. Okay? All right, so the one I want you guys to graph now is I want you to graph y equals 4 times the cosine of theta plus 2. All right, so you guys graph that one. Okay. All right, so now let's move on to the next one. Again, I'm going to keep that original function up there for reference. All right, the next one I want you guys to graph now is going to be 3 plus the cosine, 3 plus cosine of theta. Now notice how this number, I'm not adding on the end, I'm adding in the front. So I'm going to give you the vertical shift in the amplitude, and I'm going to have you guys just graph it. Just because that number is in the front doesn't change anything. You're still adding 3. So the vertical shift is still plus 3 here. It's just the numbers in the front. If you guys look at your packet, number 5 is kind of like that, where you notice that it says 2 plus 4 times sine of theta. It's just like this one where I'm adding it, but I'm just adding it before the sign. It doesn't change anything. It's just written in a different spot. So whatever you're adding to or subtracting from this function is your vertical shift. All right, now no, there's no number in front of the cosine, so that means your amplitude is 1. Okay, so you guys graph that. Okay, now as a little review, I want you guys to also graph a sine function. So I want you to graph y equals 3 times sine of theta minus 5. Now remember with this one, use these y values now. Start at the middle of start in the midline. Remember that starts in the middle. Here, I'll show you a sine graph, the base function. Start in the middle, then you go up above at 90, come back to the middle at 180, go below at 270, and then come back to the middle at 360. So that's what your sine graph should look like, except remember now, you've got an amplitude change and a shift change. So you're basically going to change that sine graph and with these changes. Okay, so go ahead and graph that. All right, and you can always check on Desmos to double check your work. All right, so all right, that's it for review of that. And also here on the back of the packet, just notice here, you're given the graph this time, so you're going to need to actually write out the equation. So what you want to do here is figure out where is your midline first. And you notice here the midline for this is right at 0. So you can put plus 0 at the end of the function there, and then figure out the amplitude, and then just write out the function. This one, the midline's right at 0 as well. Here's the midline for that one, right at 1. Here's the midline for that one at -1. All right, and the thing you got to pay attention to here is, where does it begin? Does it start above your midline or right at the midline? If it starts above your midline, you're dealing with cosine. If it starts right at the midline, it's going to be sine. Okay? So in other words, here, if it goes like this, that's sine. But if it goes like this, starts above, goes below, and then comes back up, that's going to be cosine. Okay? So if you guys look here, notice how that goes above, right? So that should let you know which one that is, so that, or whether it's cosine or sine. Notice how this one starts right on the midline, so that should tell you which one to start, which one to use. And then this one starts above, that one starts right in the middle. So that should tell you which of these functions you should be using for each of these, okay, when you set up your function. All right. Okay, now this last one I want to review is roots. Okay, with the graph, find the roots. Okay, so as a quick review here, I'm going to make kind of a mini graph here with this little section here. All right, so let's just say that my graph comes up through here, comes back through here, and it kind of touches 1 here, but then bounces back up. Okay? Find the equation, right? So the first thing you need to answer is, what are the roots? Okay, well, the roots are, let's see, it's at -3 and at +1. And at +1, it bounces. So we got to keep that in mind. Then let's find a y-intercept if we can, because we need to plug in a point to find an accurate equation. So y-intercept is usually the easiest. And notice it crosses right there at 2. All right, so the y-intercept is 0, 2. Now let's set up your equation with the a value. Okay, so first let's do y equals a times the root. The first root is -3, so here I'm going to put x plus 3. Remember, we switched the sign here. The next one is going to be x minus 1, but it's a double root because it bounces off the graph, so here I need to put squared. All right, now I need to look for that a value. Okay, so now to find the a value, I'm going to plug in the y-intercept. So I'm going to plug in 2 for the y here, and the 0 for the x. And then we're going to basically simplify and solve this equation. All right, so here, 0 plus 3, that's just 3. And then here, 0 minus 1 is -1 squared. Then I need to square that 1. So -1 times -1 is +1. Okay, then 3 times 1 is 3. Then divide by 3. We get a equals 2/3. All right, so that's my a value. All right, so once I have my a value, now write out your equation. 2 over 3. And then basically I rewrite the equation, but I just include the a value this time. And I don't need you guys to put in standard form. We're just kind of reviewing in factor form. Obviously, if you had to do standard form, you'd have to multiply all these out and combine like terms. All right, so the one that you guys are going to do, all right, let me kind of use a new color. All right, this is your graph. Your graph is going to go up through here, come back down through here. It's going to bounce right there. Let me actually make that bounce a little more clear as to where it's bouncing. Okay. All right, so that is your guys' graph. I want you to write out the equation for this graph. Okay? All right.